So, all right. Well, this is notice there's nothing on the wall back here. Friday has not an A day nor a B day. I could get Nugget. Well, Nuggets are nearby. And they got Jackford on your head, huh? Okay. Jackford. All right. Yeah, this week is our fall break, so there's no classes on Friday, and there's no classes on Monday, so you have a 4-day weekend. I will not be posting any assignment until Tuesday morning, so we'll meet on Tuesday to go over next week's. So pretty simple, straightforward. Wednesday next week is PSAT for juniors, and I think sophomores and seniors got a different project they're doing. Seniors will be up here doing the work keys that's required for graduation, and freshmen have something with community service. So everybody's busy next Wednesday. No classes Wednesday because we'll all be doing a bunch of other crazy stuff. But we'll manage through that. So, all right, this may be all we're going to have today. We're going to have a few Cali absence here today. All right, so we've got a little bit to cover today. Actually, there's a lot. It's one lesson, but we cover a lot in this lesson. Get my paper ready. Oh, it gets so bad here. So let's get to the important stuff first. Where's all right, just looking to see if I miss anything. All right. Let me put up here let's get to the important stuff first, and then we'll do the algebra. Important stuff is it's Fat Bear Week. Today's actually the last day. It's been Fat Bear Week since last Wednesday. So I just Google Fat Bear Week, and it'll take me to there's the voting site. I'll up that and the Katmai National Park and Preserve in Alaska has Fat Bear. Where's last year's winner, 747? Well, he was a big boy. He got eliminated this year. He didn't make it to the finals. But let's see. Let's look at the bears that are in the finals. If I go to the voting tab here, it's pulling up. Fat Bear Week. The voting starts at 11 a.m. our time, 9 o'clock Alaska time. Poll number 1. This is the finalists, the final 2 bears to be crowned champion of Fat Bear Week. It's loading very slow. There's no second vote. Here's the bracket, though. There's a bracket. All the bears have been eliminated. We're down to the last 2, 32 versus 128. The last 2. And here they are, right here. Chunk versus Grazier. Chunk has never won. Grazier's won once. Chunk is really big this year. I think he's got a chance to win it. I'm going to vote for Chunk when voting begins at 9 a.m. Pacific, 11 o'clock our time. Chunk, when I go back and look at this page on Meet the Bears, there's the bracket again. Chunk's the first one here. This shows him back when he came out of hibernation in the spring, and then now getting ready for hibernation here in the fall. Oh, he's a big boy. Chunk's got a big belly there. He ate a lot of salmon this year. So, yeah, there's where he started the year. Here's where he's ending the year. So I think Chunk should win this. He should get his first win this year. He's a big boy. His competition's down here. Grazier. There's how Grazier started the year and ended up the year there. So hanging out in the water, catching salmon. But vote today at 11 o'clock for your favorite fat bear. And if you don't have a favorite, vote Chunk. Vote Chunk. I want Chunk to win this. All right. Let's actually look at some algebra since we're here. Why not, right? Algebra day. All right. 5th hour. Here we go. Let's see what we are looking at this week. Let's go to our grade screen to see where we stand. Okay, we are right here. This was Sunday. We had 2.06, 2.07. This week, Sunday is the 15th. So we have polynomial operations and then the practice test. The practice test. I will tell you that I have taken the practice test and I have video recorded it. I'm in the process of editing it and getting it uploaded. So I will have it in Buzz. So if you take the practice test, and put it like that. If you take the practice test and you're missing some questions and you can't figure out what's wrong, I swear I had that right. I don't know what's wrong with it. Then go look at my video. which will be posted today. Go look at my video and say, okay, I had trouble with number 11 and 12 and 13. Fast forward to if you did the first 10 and had no problem with them, why watch me do the first 10? Fast forward to number 11, 12, and 13 and watch how I do it. And I explain my process the whole time when I'm doing the practice test. Okay, so this is now I need to do this, now do this, and I explain how I work each problem. So if you take the practice test and struggle, look and see how I did it. And then if you still don't understand it after you watch me do it, get with me before you take the test. Say, hey, I don't understand number 15. I watched you do it on the practice test. I still don't get it. How did you do that? Because the test is probably going to have a similar question. If you can't do it on the practice test, you can't do it on the test, right? You need to understand what you missed. So use the practice test wisely. It's there for your benefit because it doesn't count as an EOL. It counts as a practice grade. So use it for your advantage. So just wanted to throw that out there before we get back to this week's lesson. So we will look at the 2.08 polynomial operations today. And there's a lot in this. We do a lot of operations in the polynomial operations 2.08. So let's go over to activities. Down to the polynomial operations lesson right there. And let's see what all we're going to learn today. You might want to take notes for the test. There's a lot to cover and a lot of things we're looking at with polynomial operations. Okay, here's a little video. I'm not going to play the video. It's really cheesy. It's like watching The Sims. Got this little computerized folks there and framing a solution. I'll show it here, minute 16. But you can watch it. It's got this little girl here that broke her picture frame, and she's trying to figure out how the size of a new picture frame. But it's all it's a little computer. It's a little sim thing there, a simulated video. But it talks about how to find the size of the picture and all that kind of good stuff. You can play that. The picture's 3 times as long as it is wide. I'm not going to play that in class because videos don't always do well in class anyway, and it's really kind of cheesy. But it's talking about how to solve the problem to figure out how big a frame she needs. So we're going to look at the operations needed to do that. So let's talk about this: a closed system. Closed system. This is a math term that we use. We don't use it a whole lot. We don't talk about it a whole lot. If you get into college and get into some higher math, they'll talk about this a lot more. So I want you to have at least an exposure to it here. Have you ever heard the expression, if it walks like a duck, sounds like a duck, it's probably a duck? Well, the same can be said about math. It walks like math. If it sounds like, no, it doesn't go exactly the same. When 2 integers are added, the sum is always an integer, right? An integer is a whole number like 2 or 0 or -5 or 12. If you take 2 integers and add them together, you're always going to end up with an integer. You'll never get anything else. If you take those 2 integers and subtract them, 2 minus -5, it's 7. That's an integer. If you take 2 integers and add them, you take 2 integers and subtract them, you're always going to end up with an integer. You cannot get anything but an integer. If you multiply them, take 2 integers and multiply them together, you're always going to get an integer. There's no way to get anything but an integer. You're not going to get a decimal number. You're not going to get a fraction. You're not going to get pi or anything like that if you take 2 integers, add, subtract, or multiply. So we say that the system of integers is closed for these operations. It's closed because if you have the integers and you're sitting in a room which is full of integers, you don't have to leave the room for any answer you get. You're always going to be, you can keep the door closed and add 2 integers, subtract 2 integers, multiply 2 integers, and you'll be able to find the answer in the same room, in the same set, without having to go out to the decimal room or whatever. It's closed. Now, it's not closed for division. Because if we take 2 and divide it by 3, we do not get an integer. We have to go over and grab a fraction, a decimal, a floating point number. So for division, it's not closed, but it is closed for addition. So let's have a little exposure to that term. We don't use it a whole lot, but it is a mathematical phrase that we use from time to time. All right, let's move on and look. Polynomials are closed. If we add polynomials, subtract polynomials, multiply polynomials, we'll always get a polynomial. So, all right. Important thing when dealing with polynomials, with adding, subtracting, all this, like terms. Like terms becomes very important because you can mess it up really bad if you don't understand like terms, right? And you know, these aren't exactly great because they're very different. Like 4f goes with 7f, right? And those are like terms. Let me put up a paper up here and look at it just a little differently. So if we're talking about like terms, a lot of times it's when we have a polynomial. If we have 4x to the fourth minus 3x to the third plus 2x to the fourth minus x plus 2x squared minus x squared plus 5. Let's do something like that. I just did a lot of crazy stuff there. We can simplify this expression, but only by combining like terms. We can't take all of these x's and say 4 minus 3 plus 2 minus 1 plus 2 minus 1. Okay, so we got like 2x squared. No. We only can combine things that are like each other. X to the third, there's not another x to the third. It has to stay by itself. X squared, we have two x squared terms. Let's see, x is by itself, and the 5 is by itself. So when we simplify this, we can only combine terms that are the same. 4x to the fourth plus 2x to the fourth. So that means we have 6x to the fourth. There's only one x to the third term, so it just stays like it is. We have two x squared terms. We have a 2x squared and a negative 1x squared. So we have just 1x squared. We only have one x, and we have one that's just a number. So that's simplifying, but only can combine like terms. So that's what this is talking about right here. What are the like terms? If we have 3x squared y, which term could it be combined with? It cannot go with the 12xy because this is not x. This is x squared. So you have to put the x squared y with the 9x squared y. And then, of course, the 6xy, 12xy. This is the only one that has b's and c's, so we can only put it with the b's and c's. Only one that has g's and h's and the f's. So make sure you're doing like terms. So let's do a few of these examples, and we're going to look at addition, subtraction, and multiplication of polynomials starting out this lesson. So let's write some of this on paper. 7x squared plus 3x minus 5 plus, and it puts those in parentheses, so that helps keep those separately what we're doing. Okay, so I've written down the same problem they have in our examples. 7x squared plus 3x minus 5 plus 2x squared minus 4x plus 9. Again, we can only combine like terms. Those are the x squared terms. These are the x to the first power terms. And these are the numbers, or the x to the 0 power terms, if you like. If you like that way. So we can combine those, adding. Pay attention to what we're doing. We're adding. So 7x squared and 2x squared is 9x squared. 3x plus a negative 4x. It's just a negative x. It's a negative 1x, right? Plus 3 minus 4 is negative 1. And negative 5 plus a positive 9 plus 4. That's it. That's the answer. It's that simple. We just combine the like terms, adding them together, and that's the answer when we add those two polynomials. Don't make it complicated. Combine like terms. And here's a video that goes through that if you need to see that demonstrated in a minute and a half. Oops, I didn't do that. But it'll go through the whole thing and get to the same answer that we just got to right there. But it'll go through step by step for you again. Pretty simple, right? Right there. Pretty simple. Let's try another one. This one, it doesn't have videos. It has the steps written down like this. So, all right. So 2x to the third. We'll write this down. 2x to the third plus 4x squared minus x. See, we're making this a little more complicated. We're going to the x to the third plus 3x squared plus 6x plus 10. What has to happen? All right, so we're adding these two together. Now, the first thing we notice is this is an x to the third, and there's not another one. There's nothing to add it to over here. So it's going to be by itself. There's the x squared terms. Here's the x terms. And then just the numbers. Right. So when we write our answer, we start with the largest term, 2x to the third. Okay, so we're done with that one. 4x squared plus 3x squared. So we have 7x squared. We're done with that one. We have a negative 1x plus a positive 6x. So we have 5x's. We're done with those two terms. We have 7 plus 10. Okay, there's our answer. 17. 2x to the third plus 7x squared plus 5x plus 17. So we add those together. It's okay that this one doesn't have an x to the third term. We just bring that down. It does have an x to the third term, but it's 0x to the third. That's why we didn't write it. Every polynomial has an x to the third term, just most of the time it's 0. So we added 2 plus 0 to get 2x to the third. So, all right, let's look at the next page. We're going to get into subtraction now, I expect. Oh, look, subtracting polynomials. All right, this is where you're going to make a very simple mistake if you're not careful. Let me write this one down. Minus 7x squared plus 3x minus 4. Okay. All right. If you're not careful, there's a very common mistake that when there's a mistake made, 80 to 90% of the time, it's always the same mistake. We are subtracting. That's the important part to remember here. And we're subtracting everything inside the parentheses here from what's in the parentheses here. All right, like terms, 9x squared and 7x squared. Subtract those. 9 minus 7, we have 2x squared. You'll do okay with that. Most of the time, I expect that'll be fine. But how about when we have x minus 3x? Okay, that may trip you up a little bit, but this is 1 minus 3. Okay, but here's the one I'm going to see 80 to 90%. When there's a mistake, and you won't always make this mistake, but when you do, you're going to say, I got 2 minus 4, and you're going to say, that's okay, I got negative 2. No, you don't. Because you're subtracting negative 4 from 2. This is 2 minus negative 4. 2 minus negative 4 is not negative 2. This is wrong. Get rid of that. When you subtract a negative, you add. 2 minus negative 4 is 6. But that's where you're going to slip up. If you make a mistake, most likely it's going to be you forgot that you're subtracting a negative, which means you add. And I will see negative 2 here as an answer when you make a mistake. Hopefully, it's very rare that you make that mistake. But when you do, it's probably you forgot you're subtracting a negative. So pay very close attention when you're subtracting and you have a negative value. Because that means you add. Subtracting a negative means you add. So they have a video here that lasts minute 28 to get to that same answer. plus 6 at the end, not minus 2 plus 6. All right. Let's see. This is a good one. Let's do this one. 4x squared minus 5 minus x to the third plus 2x squared plus 7. It's tricky to do this with a cat on your head the whole class, but that's all right. We can do it. All right, so 4x looks right here. I read it down correctly. All right, so we're subtracting. Right away, we see we have an x to the third over here, but we don't have one over here. We can add one if it makes us feel better. We can say, okay, there's a 0x to the third over there. There is. We just don't write that because it's got a coefficient of 0. But if it helps you keep it straight. So this is 0x to the thirds minus 1x to the third. We generally don't write the 1. If you want to write that 1 to help you remember that, anytime you got just an x, it's a 1. So this is negative x to the third because we're subtracting it. Yeah, that's a positive x to the third, but we're subtracting it. So this is how our answers will start. We start with the largest exponent, and that's going to be the largest exponent. So 0 of them minus 1 of them. Now we have 4x squared minus 2x squared. So we still have a positive 2x squared. We have negative 5 minus 7. Negative 5 minus 7, negative 12. There you go. All right, pardon me a second. Sorry, I got this cold this weekend. It's just bothering me today. All right. Let's go back here. All right, so they end up with the same answer. Negative x third plus 2x squared minus 12. All right, and let's see. They're looking at the previous example and talking about what would happen if you didn't remember you're subtracting everything. But you could also distribute a negative 1. We'd have negative x to the third, negative 2x squared, negative 7. So they kind of dig in that and see how your answer could go wrong if you didn't distribute it correctly. So this is the answer you should have had, and you could end up with this answer by mistake if you don't pay attention to that subtracting of every term. Like if you don't put that in parentheses and you only subtract the x third and then forget about subtracting these and you add those, that's some of the common mistakes that you can see happening there. All right, distributing, multiplying. So we did adding, we did subtracting. Now let's look at multiplying. Uses the distributive property. All right, so multiplying by a monomial, a binomial, a polynomial, anything like that. So here's an example they do. So we'll write this one down. 3x squared times, and then they put it in parentheses, 5x squared.
Which part, Maddie?
My 5 looks a little sloppy there. Okay, here's their problem they do right here. 3x squared times. Okay, well, parentheses mean we distribute. So we're going to take the 3x squared times that, and then we're going to do it times that, and then we're going to do it times that. And since there's only one term out here, we only have to do this once. Just have one term. So 3x squared times 5x squared. Well, 3 times 5 is 15. But x squared times x squared. You got x times x times x times x. Because that's x squared and that's x squared. So this is x to the fourth. Right? Because you got x times x times x times x. So now we'll do the second one. 3 times 7 is negative 21. X squared times x. Now it's x to the third. 3 times 8 is 24.
The one I have highlighted on the screen.
X squared times just 1, because this is just x squared. So it's 8 times 3x squared, 24x squared. All right, so that's a monomial, one term, mono times a polynomial. Binomial does the same thing, except you have to distribute twice. X minus 7 squared is x minus 7 times x minus 7. So it goes through the steps to do that. You got to distribute the x and then distribute the negative 7. But let's look at this one instead.
Did you have an opening?
There we go. All right, so we'll do this example. 4x squared minus 5x plus 9 times x minus 5.
Okay. Or the food chain is one after the other.
Okay, the way they have to set this up is we would distribute to both terms. All right, so we're going to distribute 4 squared times x and then 4 squared times negative 5. Then we'll go to the negative 5 or do it, and then we got to do the 9. Now the other way you can do this, if you don't want to do this way, you can move the x minus 5 over here and just distribute the x and then negative 5. It works the same way. 2 times 3 or 3 times 2, it's 6 either way. All right, so but we're going to leave it like they have it. So 4x squared times x is 4x to the third, because x squared times x would be x to the third, and 4x times negative 5, so negative 20x squared. Okay, we've done that term. Now let's look at this one. Negative 5x times x, negative 5x squared, negative 5x times negative 5, plus 25, because it's got a negative times a negative, x. Okay, we've done that term. Now 9 times x is just 9x. 9 times negative 5 is negative 45. So we've done all 3 of them now. Now we just need to combine like terms. So we have 2x squareds and 2 x's. 4x to the third, negative 20 and negative 5. So we have negative 25x squared. Positive 25, positive 9, 34x minus 45. So that's the answer. When we multiply these 2 polynomials together, we get a bigger one that's x to the third now. So that's examples of adding, subtracting, and multiplying polynomials. Let's see what we're doing with it next here. All right. Equations versus functions. We've talked about functions. That's nothing new. We talked about that in Algebra 1. We've talked about that in Algebra 2. Nothing new. We can have an equation that's not a function, or an equation is a function. So this is x squared plus y squared equals 1. Well, we know if it's a function, there's only one y for every x. This is the equation of a circle, and we know there's going to be more than one y for every x. Look, when x equals 1/2, there's 2 different y's. Y equals the square root of 3 over 2 and negative square root of 3 over 2. When x is 0, y equals 1 and negative 1. So there's more than one y for an x. That is not a function. X plus 7 equals 10, which we simplify that, it's x equals 3. That's a vertical line. That's not a function. It fails the vertical line test because there's an infinite number of y's for the same x. X equals 3 and y equals infinite number of y's, positive and negative. So that's not a function. But the last one, last 2, y equals 2x plus 3, that's a linear equation. That only has one y for each x. And this is a quadratic equation. It's a parabola. That only has one y. So 2 of these are functions and 2 of these are just equations, but not functions. So the vertical line test, right? And we can illustrate that with our Desmos graphing calculator. There we go. All right. So y equals 2x minus 5. Let's just throw that out there. Okay, that's a linear equation. If we want to check to see the vertical line, anywhere we put the vertical line, it only touches the graph once. There's not any place where there's 2 y's for any x. Same thing if we make this a parabola, there's still only one y anywhere along the parabola. But that equation of a circle they had, x squared plus y squared. I'm going to make our circle bigger than what they had. They had equals 1, so they had a very small circle. I'm going to do a bigger one, say 25. Like 25. There we go. See, we see there's several places where there's 2 y's for every x. Now over in the end, there's only 1 y right there, and there's only 1 y over here. But all I have to find is one place where that fails, and it's not a function. And there's several places where this fails. So the vertical line test is a great way. Graph your function and see, is there any place where there's 2 y's for 1 x? And when x is 0, the y is 5 and negative 5. All right, function notation, we've talked about that before. Instead of y equals 2x plus 3, you can say f of x equals 2x plus 3. That's just writing it in function notation. So here's more. If you need more help with that, show more on function notation, and this will explain it further. But we've talked about that. Function notation. If we say f of 4, that means substitute 4 in for the x, right? And figure out what that equals. Talks about domain and range. If you need more help with domain and range, it'll talk about that again in this little click box right here. So it'll talk about domain and range. Let's go over to page 6. See what it's teaching us over here. Inverses. I think this is the last of our lesson. Nope, it's not the last of our lesson. We don't have our lesson summary on this page. Inverses. So an inverted roller coaster is a ride where the cars are underneath the track and they travel along beneath the track rather than above it, where you're hanging underneath it. I've ridden an inverted roller coaster up in Cedar Point, Ohio. Cedar Point is an amusement park that has I think they have 21 roller coasters now. They had 19 when I was there, and I rode every one of them. I think they're up to 21. But they have an inverted roller coaster, and it's very different hanging underneath it. You move differently than when you're sitting on top of the track. If you have an inverted airplane, it's flying upside down. You find videos of inverted airplanes where instead of flying right side up, they're upside down. Inverting the colors on a photograph turns black colors to white and white colors to black. It looks really weird because the colors are all wrong from what we're normally experiencing. So inversion is the process of reversing something, either the order or the position, but you're reversing something. So if you want to find the inverse of an integer, that means you're going to perform an operation and we'll cancel it out. Like if you have the number 7, you can say, I'm going to add a negative 7 and make it 0. I'm canceling it out. That's an inversion process. Or I could say, if I multiply 7 by 1/7, that equals 1. That's another way of finding an inverse of the number 7, is finding the reciprocal 1/7 and multiplying it by that. So with equations and consequently functions, finding the inverses requires reversing the variables and solving for y. So we're going to take this one they've got here, and we're going to find the inverse. So you're going to want to write these steps down if you don't already have them memorized. You should have seen inverses before, but let's see. So we're going to write f of x equals 3x minus 5. And we want to find the inverse. We want to find the inverse. So there's 4 steps that we do here. Step 1. Rewrite as y equals. So we're going to take it out of function notation and write it as 3x minus 5. That's step 1. Hey, that was pretty easy. Well, step 2 is easy too. Swap x and y. Every time you find a y, make it an x. Every time you find an x, make it a y. Just like that. That's step 2. We had y equals 3x minus 5. Now we have x equals 3y minus 5. We just swapped them. Everywhere is an x, make it a y. Every time there's a y, make an x. 3. Solve for y. Solve for y. So we need the y by itself. Add 5. 5 plus x is not 5x. That's 5 times x. If we're adding it, they're not like terms. So they become separate x plus 5. They're not like terms, so we cannot combine them. X plus 5 equals 3y, because these cancel out. Negative 5 plus 5. Divided by 3. So x plus 5 divided by 3 equals y. Okay, we've solved for y, because we have y equals. Step 4. Rewrite as, and this is how you write the inverse notation. F with the little -1 up here of x. So the inverse of the original function is x plus 5 divided by 3. This is the inverse of this. Because we went through these 4 steps, 1, 2, 3, 4, and that's how we get the inverse. We have seen that before. I don't think it's totally new, hopefully, but if it is new, make sure you have these 4 steps written down and probably some examples to go with your 4 steps. A lot of times we read the steps, and it's like, I don't understand what the step means. Well, write down some examples next to it so you can see. And maybe you even need to label the steps. 1, swap x and y. 2, this is step 3, and this is step 4. So maybe you need to put the steps there along with it, with your notes. Something to where you understand what you're doing for the inverse. All right. Let's go back here. So they have a little video where they step through the whole thing again. If you need to see that done again, 1 minute and 7 seconds, they come up with the x plus 5 equals y. And I think, and then they change it to the function notation. F -1 of x. So, oh, graphing that. Great. Let's do that. I want to look at this. Okay. Y equals 3x minus 5. Okay. That was the original equation. Then we said the inverse, y equals, I got to put it in parentheses, x plus 5 divided by 3. If you don't put that in parentheses, show you what happens. Let's just do x plus 5 divided by 3. Say it does 5/3. That's totally different. So if you put the x plus 5 in parentheses and then divide it by 3, it'll do it correctly. All right, so here's something we want to look at that. So we said this is the inverse. We have the original equation, which is the red one, and the inverse, which is the green one. Now let's look at this point here. I'll type the point. 4,7 is on the original equation, right? And what did we do to find the inverse? We swapped the x and the y. Well, can we just do that with the graph? Instead of 4,7, can we just do 7,4? We just swap the x and the y? Yes, that is on the inverse. Any point you find on here, you'll find the opposite point on the inverse because we swapped the x and y. That was part of the process of finding the inverse. So if you have these points, you can use the opposite of the point, 3, 4. Here we got the point 3, 4 on there. 3, 4. That's on the original line. So that means we should find on the inverse 4, 3. And we do. So that works for every point that you can find on the original equation. We have 0, -5 on the original line. So that means we have -5, 0 on the inverse. Label. There it is. And since we swapped the x and the y, that means if we put the line y equals x, it's a reflection over the line y equals x. So an inverse will reflect over the line y equals x. Because the y does equal the x. See, this y equals this x, and this y equals this x. The y's equal to x's. on both sides of that line. Cool thing about inverses. So if you just have some points on a function, that means you automatically have points on the inverse function. You just reverse them. All right, so now it finds the inverse of a little trickier one. We'll do this one too. F of x equals x squared. Oh, we follow the same steps. First we rewrite. Then we swap x equals y squared. Now we need to solve for y. So to solve that for y, we got to take the square root. The square root of y squared is just y. And it equals the square root of x. So if we rewrite it in function notation, the inverse of f of x equals x squared is f inverse is square root of x. Square root of x. Now, when you look at that, when you graph it, it gets a little funny. Let's take all these off here. Because when we graph y equals x squared, it's a parabola. But if we take the inverse of that, it would not be a function. Because if we did x equals y squared, see, that's not a function because there's two y's for every x. So the inverse looks like this, square root of x. It only is the positive value. We have to restrict the domain. We have to restrict the domain to x is greater than or equal to 0. Just because it wouldn't be an inverse for all of x. But this is a reflection of y equals x. All right. So inverse functions can be solved for a specific x value, just like any other function. Here's another example. Change the f of x to y. Swap the x and the y's. Solve for y. Subtract 2 from each side. Divide each side by 6. Right there. X minus 2 divided by 6 is what it equals. You can change it back to inverse function notation. Now we can solve it for 2. Let's just say if we're solving the inverse for 2, it's 0 over 6, which is just 0. So, all right, so not every function has an inverse that's a function. That's like this one. The inverse of that would not be a function because it would be 2 y's for every x. They show the same thing here, plus or minus. Let's see if you did plus or minus. Plus or minus. Oops. There's the minus version of it. Yeah, it wouldn't be a function for both plus or minus. Doesn't pass the vertical line test. But restricting the domain would make it just show the x part up there. All right, let's look at the next page, page 7. Equations versus functions. All right, so we learned what makes an equation a function. Only one y for every x, right? Each x value in the domain corresponds with only one y value in the range. So it passes the vertical line test. So we can write it using y equals. We can also write it using f of x equals. Same thing. But f of x means substitute the value of x into a function of x. It doesn't mean multiply f times x. So let's look at function composition. All right, this is where it may get. If you don't practice this is what I see constantly. We get these function composition problems, and students do not practice this. And then we have them on the assignment, we have them on the test, and you're totally lost. Totally lost. So I'm going to do some examples of function notation with the composition. So f of x equals this equation. G of x equals this equation. And we can find, we're used to something like this. If we said f of 1, what's f of 1 equals? Well, that means I go into this equation, and everywhere there's an x, I'm going to make it a 1. Whatever I put in the parentheses, that means take out x and put in this. Right? So, well, let's see, 2 times 1 squared. Well, that's just 2. Negative 4 times 1 is negative 4 plus 1. 2 minus 4 plus 1, negative 1. So f of negative 1 equals negative 1. That's what that equals. Great. I can do that. Just whatever I put there replaces the x. That's the basic principle of function composition. So if I do this, what am I expecting to happen? Same thing that happened up here. When I made this a 1, I substituted a 1 in everywhere there's an x. Now, instead of putting a 1, I'm putting a g of x. So that means I go into the original equation, just like I did, 2 times, instead of x, I'm putting g of x. X squared plus 3 squared, because the x is squared, minus 4 times x squared plus 3, because that's what x is, plus 1. So this is the exact same equation as this, except anywhere there's an x, I've substituted g of x into it. Right? We can see that. Now this is going to be a little complicated to simplify because I've got to do all this math, but we can do that. X squared plus 3 squared. Oh, let's work that over to the side. X squared plus 3 squared. Well, that means it's x squared plus 3 times x squared plus 3, right? That's what it means to square something. So let's distribute. X squared times x squared is x to the 4th. X squared times 3 is 3x squared. Now distribute to 3. 3 times x squared is 3x squared, and 3 times 3 is 9. So that's what x squared plus 3 squared equals. So I'm going to multiply 2 times that, because that's what that is this right over here. So 2 times that. So f of g of x is 2 times x to the 4th times 2 times 3x squared. So that's 6x. Oh, x. Yeah, it's x squared. Oh, wait. I didn't simplify this. X to the 4th. Those are like terms. And these are both x squared, so I can combine those. So down here, when I take 2 times that, now I've got 12. 12x squared. And then 9 times 2 plus 18. Okay, so that's that first part. Now I've got negative 4 times x squared plus 3. So negative 4x squared. Negative 4 times 3 is negative 12 plus 1. So what can I simplify here? I have an x squared term and an x squared term. And I have 3 numbers, 18 minus 12 plus 1. So this will simplify to 2x to the 4th, because there's only one of those. I've got plus 12x squareds and negative 4x squareds. So that means I've got 8x squareds. 18 minus 12 is 6 plus 1 plus 7. So that is what f of g of x equals. If you don't practice doing this, you will get lost and not have any idea what to do when we do problems on the test. Now, let me show you where you're going to see this on the test. We found the inverse of this. Can we prove that's the inverse? Well, yeah, graphing, but we can prove it algebraically. And the test will say, prove this algebraically by, here, let's do this. Let's call one of them f of x, because this is what you'll see on the test. 3x minus 5. That's the first one that we did up here. This one, we'll just name it g of x. We can call it whatever we want to call it. And it was x plus 5 over 3. Okay. Test alert. Test alert. You will see this on the test. You'll see an f of x and a g of x. And it says, prove that these are inverses by doing this. F of g of x and g of f of x. We have to do both of these to these equations. And if they're inverses, they will both just equal x. But we've got to do them. We have to show the steps on the test. So let's do that. Let's start with this one. F of g of x. So 3, instead of x, remember I'm substituting. So here's what x is. X plus 5 divided by 3. I substituted g of x exactly where the x is. And then I've still got that minus 5 out here at the end. Okay, so now we simplify. So that equals, well, this is 3 times x plus 5 divided by 3. Well, if you divide by 3 and then multiply by 3, those cancel each other out. So this is just x plus 5. And then we still have minus 5. So what's x plus 5 minus 5? Well, okay, so that just equals x. If I substitute g of x into f of x for the x and simplify it, it just equals x. So far, so good. Now I have to do this one. G of f of x equals what? Instead of x, I have 3x minus 5 plus 5 divided by 3. See, same equation, except the x became 3x minus 5 because that's what f of x is. Now we just simplify. I really don't need the parentheses there because there's nothing outside. There's just a 1, so it's just 3x minus 5. But 3x minus 5 plus 5, what does that equal? Well, it just equals 3x, right? Because these cancel each other out. Minus 5 plus 5. Divided by 3. Well, what's 3x divided by 3? Well, it's just x. So I have proven algebraically that f of x and g of x are inverses of each other because they both equal x when I substitute them into each other. You will see this on the test. You'll probably see this on the assignment, but you have to know how to substitute one into the other one and simplify. I have to show these steps. I got to show how I got there. I can't just say f of x is that equals x. Well, you didn't show me that. You just stated that. Oh, it equals x. Well, can you show me that it equals x? I can if I do this. Substitute it in, simplifies to this, simplifies to that. Okay, I believe it now. But you can't just say it. You got to show it. So you will see that. So it's good to practice that. All right. So here's one you can try. X minus 2 divided by 6 and 6x plus 2. Verify that those are inverses of one another by doing f of g of x and g of f of x and showing that they both equal x. You could try that on paper. And then you can look here and say, okay, did I do that right? Because they did both of them right there and showed the equal x. So this is a good one that you can practice on paper to see if you know what you're doing. Here's our lesson summary, which talks about the addition, subtraction, multiplication, adding polynomials, subtracting polynomials, multiplying polynomials, and then the function composition, substituting f of g of x, which you may see like this too, f of g of x. Right, so you can see it different ways. It just means to substitute one into the other. So adding, subtracting, multiplying, and composition of functions. That's what we looked at in this lesson. Now, with that, they give you some more practice problems. There's still 2 pages that if you want to make sure you understand, you said, I think I got it. I think I got it. Well, this is how you can know if you got it. Work these problems. These are addition. Add this polynomial to this polynomial. Can you get the right answer? There's 4 of those. Then go over here. These are subtraction. Subtract this polynomial from that polynomial. Can you get the right answer? There's 4 of those for you to try. Then here's multiplication. It starts out with a really easy one, -3 times this polynomial. And you can check your work right here. Did I do it right? Did I get the right answer? There's the right answer. Did I get the right answer? Next, here's one that multiplies 4x squared times that. Did I get the right answer? There's what the answer should have been. There's 9 of these because they get more complicated. Look, now we're multiplying 3x times 5x times this polynomial. Here's what the answer. And the easiest thing to do is multiply 3x times 5x first. Oh, and they left out the x. It should have been 15x squared. They left out the x in their answer. They got a goof. 15x squared times that. Here's another one. X minus 8, x plus 5. You can use FOIL. Okay, so it gives you 9 practice problems. And then over here, it gives you f of x. F of x is 3. G of x is 6 plus 4. And they want you to find, add them together, subtracting them, and multiplying them. This is the answer of one of them. This is which one? This is subtraction. If I subtract f of x from g of x, I get that. So there's 3 of those problems right there. The next page has practice problems, I would imagine, with inverses. See if it gives us inverses. Nope. First, it gives you some more addition. Gives you some more problems to practice. Activity 2 adds them together. Check your answer. Here's another one. Subtraction. Check your answer. Multiply them together. Check your answer. Multiply them together. Check your answer. And here, the last one has the composition. G of f of x. So here's another one to practice. And this one, you got to take G, which is the big one, and substitute x minus 4 into there. And there's where you can check your work. See if you got it right when you simplify it. Very important to practice composition because you're going to do this now. You're going to do it in Algebra 3 as well, or in other math classes. If you take Algebra 3, you don't have to take Algebra 3. You have other choices for your 4th math class. Algebra 2 is required, but you will see that again, composition. Let's look at the assignment. Addition of 2 polynomials. Subtraction. F of x minus g of x. Subtraction. Multiply. Which of these represents the area of a rectangle? It has a length of this and a width of this. Area is length times width, which means you're multiplying these 2 together. 3x plus 5 times x minus 2. Which one is the answer? Here's another one, multiplying. Multiply them together. Multiply this, 3x minus 5 squared. That means you're multiplying it times itself. Another multiplication. Number 9, multiplication. And then it says the company makes video games, so the price is this equation here. That's the price. And the number sold is this one. So what do they need to do to find the total revenue? Do they need to add those, subtract those, or multiply those? Or we don't know. We can't determine that from that. So that's it. 10 questions this week. 10 questions this week. And then you have the practice test. And the practice test has a whole bunch of questions. Let's see how many tests. I think there's 20, like I say, I took it yesterday, 23 problems, something like that. There's the review of every lesson, and then the practice test, which has, let's see, get to the bottom. 23 questions. Yep, that's right. So I will have that video of me taking the practice test posted very, very soon. So it's 10 o'clock. You got 1 hour till Fat Bear voting opens. That's the important stuff, right? 1 hour till Fat Bear voting opens. But there you got your assignment. That's the lesson for this week. That's what you need to know. So I'm finished. That's all I'm telling you today. So I'll hang around if anyone's got questions or wants to just work or whatever you do. I'll be hanging around here. But that's it for this week. That's our new lesson. All righty, guys. Fat Bear Week voting. 1 hour. It'll close tonight.